Finishing up this problem from before, we are comparing boron and fluorine. So once again, you are comparing here. This guy is 1s2, 2s2, 2p1. And then with the fluorine, you have 1s2, 2s2, 2p5 that are there. Now what it says is justify why the peaks for fluorine tend to be left of the corresponding peaks for boron. If you're not sure what that means, let's compare similar peaks. So if you compare, for instance, just the 1s's, here's your fluorine and here is your boron that's there. You'll notice that the fluorine tends to be to the left of the boron, which is more. So this is more energy. And the boron over here is less energy. So that's the 1s's. Now if we compare something else, let's compare the 2s's, for example. So here's the 2s's. Once again, this is the fluorine and it's more. And this is the boron, which is less over here. So why is it when we compare similar peaks, the 1s, for example, to the 2s, why are the fluorines more than the boron? Well, this is just another way of asking basically the same question as we did in the nitrogen and oxygen question above. Boron and fluorine, if we compare them here on the periodic table, here they are. Here's boron, and here's fluorine. So there are two things that could account for this differences: shielding and charge. Can shielding be used to explain the differences of these? And of course the answer again is no, it cannot, because in boron we are at the second energy level that's here. So here's that, we're at energy level 2, and for fluorine we're at energy level 2. So here's boron. That's this guy here. There's your nucleus for boron, and boron has one level of inner shielding. And here is fluorine. That's this guy here. Fluorine has one level of inner shielding. So shielding cannot be used to explain the differences between these two guys because they are in the same row of the periodic table. So they are at the same energy level. So if shielding cannot be used to explain it, then what can? Well, nuclear charge once again. So once again, if we come over here, boron has 5 positive charges because it has 5 protons in the nucleus, which is why it has number 5 that's there. And fluorine has 9 protons because it's a number 9. So this has 9 positive charges. So because fluorine has 9 protons, it has a greater nuclear charge than boron does, and they have similar amounts of shielding because they are in the same energy levels, it then makes perfect sense that fluorine is going to be more because it has 9 protons versus boron that only has 5 protons that are there. It makes sense that fluorine is more because it has 9 protons versus boron that has only 5 protons. So, once again, greater nuclear charge based upon the idea of Coulomb